Good morning, everyone. Now I am going to discuss about the canonical and standard forms. As you know, in digital logic, the inputs and outputs of the function are in the form of binary numbers, that is 0 and 1. Therefore, the digital logic is also known as the boolean logic. These inputs and outputs can be termed as boolean variables. And the output Boolean variables of a digital signal can be expressed in the terms of input Boolean variables, which forms the Boolean expression. The Boolean expression can be categorized into two: the sum of products and the products of sum. Sum of products, that is SOP, and the product of sum means POS. Let's look some definitions. What do you mean by literal? Literal means a variable or its complement, that is a or a bar. That. Next one is product term. Literals connected by dot operator is known as the product term. And what do you mean by sum term? The literals connected by plus, the operator plus is known as the sum term. And there is two more terms, min term and max term. Minterm means a product term in which all the variables appear exactly once, either complemented or uncomplemented. Just listen, the minterm means a product term. For example, A dot B dot C. It's a minterm. And max term. Max term means a sum term in which all the variables appear exactly once, either complemented or uncomplemented. That means it's a sum term. For example, A plus B plus C or A bar plus B plus C bar, like that. I will explain in detail what you mean by minterm. Represent exactly one combination in the truth table, and it is denoted by small letter mj, where j is the decimal equivalent of the minterm's corresponding binary combination bj. And for example, j is equal to 0. So, what is the minterm? 0 means the binary equivalent of 0 means 0, 0, 0. So, the minterm will be a dash b dash c. A variable in mj is complemented if its value in bj is 0. If the value of bj binary number is 0, then the variable in mj is complemented. That is why I told that 0, 0, 0 means a dash, b dash, c dash. So consider an example. Assume three variables a, b, c and j is equal to 3. J is equal to 3 means the decimal equivalent of 0, 1, 1 is 3. Otherwise, when j is equal to 3, then bj is equal to 0, 1, 1. The binary equivalent of 3, 0, 1, 1. So, the corresponding minterm will be, for 0, we will get a dash. For 1, we will write b. For 1, again we will write c. So, the minterm will be denoted by mj is equal to a dash b c. Next one is the max term. As I told earlier, the max term means the sum term. Sum term. So it represents exactly one combination in the truth table using the operator plus, and it's denoted by capital letter J, where J is the decimal equivalent of the max terms corresponding to the binary combination. And a variable in mj is complemented if its value in bj is 1. When the value of the bj is 1, consider this example, bj is equal to 0, 1, 1. The second term is 1. When the value of bj is 1, we'll write complemented. complemented value, that is b dash. When the value in the bj is 0, we will write the uncomplemented value, that means a. A variable in mj is complemented if its value in bj is 1. Otherwise, it is uncomplemented. Okay. Then consider this example. Assume three variables a, b, c and j is equal to 3. That decimal equivalent and we'll convert it into binary equivalent. So we get bj is equal to 0, 1, 1. Its corresponding max term is denoted by, for 0 we'll write a uncomplemented value, 1 we then plus operator, then 1 we will write b dash, plus for 1 again for 1 we will write c dash. The max term is a plus b dash plus c dash. This is the truth table for minterm and max terms for 0 to 7, 8 bits numbers, and it is represented as minterm is represented by small letter m, 0, 1, 2, etc. m7, and the max term is represented as a capital letter 0, capital letter m1, capital letter m2, capital letter m3, and like this. Next topic is canonical forms. Any boolean function f can be expressed as the unique sum of minterms and unique product of max terms. And we can say that every function f has two canonical forms. Canonical sum of products, that means sum of minterms. And the canonical product of sums, that means product of max terms. Consider this example of canonical sum of products form. F1 is equal to F1 of A comma B comma C is equal to small letter m1 plus m2 plus m4 plus m6. For getting the value of m1, consider this truth table. And for m1, the binary equivalent of m1 is equal to 0, 0, 1. That means bj is equal to 0, 0, 1. For this value we get in the column of A there is 0, so A dash, and under B the value of bj is equal to 0, so again we get B dash, and under C the value is 1, so we will write C. So for m1 we get the value A dash B dash C. So this is the sum of products, so we put the plus operator here. And for m2, the binary equivalent of m2 is 0, 1, 0 according to this truth table. So we write 0, 1, 0, so A dash B C dash for m2. And again for m4, 0, 1, 2, 3, 4, m4, 1, 0, 0. The binary value for the m4 is 100, so we write A B dash C dash plus m6. For m6 we write A B C dash. So we get the canonical sum of products, and the canonical product of sums for ABC is equal to m0 dot m3 dot m5 dot m7. So for m0, the binary equivalent is 0, 0, 0. So for 0, it's uncomplemented value. So A plus B plus C. Then m3, 0, 1, 1. For 0, it's an uncomplemented value. So A. For 0, sorry, the binary equivalent of m3 is 0, 1, 1. So here we put A plus B dash plus C dash. For 0 is an uncomplemented value A plus 1 for 1 we will write B dash, and again under C there is a 1, so we write C dash for it. For M3 we get A plus B dash plus C dash. Likewise, we will find M5 and M7. This is the product of sums form. And next, the shorthand method. We can represent these minterms and max terms using these symbols. This f1 of a, b, c is equal to sum of small letter m 1, 2, 4, 6. That means it indicates that this is the sum of products form, and m of 1, 2, 4, 6 indicates that the minterms to be included are m1, m2, m4 and m6. Likewise, f of ABC is equal to product of capital M of 0, 3, 5, 7. That means it indicates this is the product of sums form, and M of 0, 3, 5, 7 indicates that the max terms to be included are M0, M3, M5, M7. This is the shorthand method. So we can write it as sum of m of 1, 2, 4, 6 equal to the product of m of 0, 3, 5, 7 is equal to fn of ABC. Using the above said law, we can convert these canonical forms from um, SOP to POC and vice versa. For example, f of ABC is equal to a dash b dash c plus a dash b c dash plus a b dash c dash plus a b c dash. From truth table, we get M1 plus M2 plus M4 plus M6 in the terms of minterms, and it is also represented as sum of 1, 2, 4, 6. Using the above law, that means the sum of different minterms is the complement of product of other max terms from the truth table. So we get the product of 0, 3, 5, 7 from the truth table. We will convert this POS into in the terms of variables a plus b plus c for 0, capital M0, dot a plus b dash plus c dash, that means capital M3, dot a dash plus b plus c dash, that means capital M5, dot a dash plus b dash plus c dash, that means capital M7. So we can convert this product of sums, that means POS, into the sum of products terms. And now we will discuss about the standard forms. What is the difference between the standard forms and canonical forms? The standard forms are like canonical forms, except that not all the variables need appear in the individual product or sum of terms. For example, consider this example f of ABC is equal to a dash b dash c plus b c dash plus a c dash. Here in this term there is no a term, and in this one there is no b term. So in the standard forms, this is like the canonical forms, but that not all the variables need appear in the individual SOP or POC terms. Is then another example for the standard product of sums a plus b plus c dot b dash plus c dash dot a dash plus c dash. Then how to convert the SOP form from the standard to canonical form. There is two steps. In the first step, expand the non-canonical term by inserting the equivalent of 1 in each missing variable x. That means we all know x plus x dash is equal to 1. So consider this example a dash b dash c plus b c dash plus a c dash. So in the second term, there is no a. There is no a term. So we will add a plus a dash, it is equivalent to 1, so there is no change in the value of this boolean expression. So add a plus a dash in this term. And here a c dash, there is no b term, so we add b plus b dash here. So we will expand using the distribution law of Boolean algebra, and we will get the canonical form of a dash b dash c plus a b c dash plus a dash b c plus a b dash c dash. So this is the method to convert the standard form into the canonical form. And one more step is here. In the second step, remove duplicate minterms. Here look, a b c dash repeating twice in this statement. So we will know x plus x is equal to x. So we can remove the duplicate minterms. And this is the conversion of POS from standard to canonical form. Like last example, expand non-canonical terms by adding 0 in terms of missing variables. Consider this example, a plus b plus c dot b dash plus c dash dot a dash plus c dash. There is absence of the variable a, so we will add a dash. A dash means 0, right? So when we add a dash, there is no change of value. So add a dash here and also b dash here in the absence of b, and using distributive law um, we will get a plus b plus c dot a plus b dash plus c dash dot a dash plus b dash plus c dash dot a dash plus b plus c dash dot a dash plus b dash plus c dash. This term is repeating twice here, so we will know x dot x is equal to x. So we can duplicate the max terms. So remove the duplicate max terms from this statement, and we will get the canonical form of POS. Hope you understand about the min terms, max terms, POS and SOS. Thank you.